Hello and welcome back to this course on programming in Rust. So in this project we're going to build a web crawler, a program that fetches loads of web pages at once and follows the links between them. It's the perfect project to work on our asynchronous programming skills, because crawling was almost entirely spent waiting on the network for those pages to come back. We'll fetch pages, pull the links out of them, and carefully avoid visiting the same page twice. We'll also learn how to cap how many requests can run at once. So starting from a single seed URL, the crawler will fetch that page and pull out all of its links. It will then queue up the new ones to visit next. We'll use a shared set to keep track of every page that we've already visited, so we never fetch the same page more than once. And we'll use a semaphore to put a hard limit on how many requests can be in flight at any one moment, which stops us from hammering the network or the site that we're crawling. Okay, so I've already gone ahead and created a new project called Web Crawler using cargo new, and I'll open up the terminal because we're going to need two crates for this. We're going to use Tokyo for our async runtime and reqwest for the HTTP, which spell REQWEST. Pretty cool. Neither one lives in the standard library, so we need to pull them in as external crates. And now let's install reqwest. So if I open up my cargo toml file, get out of the terminal, I can see that request and Tokyo have both been installed. Okay, so let's start by writing some logic to fetch a page. Now, fetching a page is two awaits, one to send the request and one to read the body back as text. So let's add the following. Okay, so these question marks are going to pass any network error straight back up to the caller. See the question marks at the end of the wait? That's the question mark operator and result error handling that we've used before. Now let's work on extracting links. So for this, I'm going to be using my own blog. So there are three types of links. There are pages that kind of stay on the same site. There are links that go to other sites. And there's also assets like CSS and images. For our web crawler, we're only interested in the first kind. So what we're going to do is we're going to scan the HTML for an href quote and then tidy up what we find. Now, a real HTML parser would be a lot sturdier, but scanning this is enough to see how all of this is going to fit together. So underneath your fetch function, let's write the following. Okay, we've written a lot here, so let's go through this slowly. So this is an iterated chain, just like the ones that we've built previously. We grab the text inside each href, turn the root relative link like /post into a full URL, keep the ones only on our own site, and we also drop style sheets and images. We also trim any trailing slash in our normalize function. So a link that ends in a slash and one that doesn't will count as the same page. Now this same site filter that we're using is an important one, and it's going to stop our crawler from wandering off onto the rest of the internet. So a lot of tasks are running at once, and they all share one set of visited URLs. This is the Arc and Mutex pattern that we've used for shared state, except this time we're using Tokyo's async aware mutex instead. These imports we're going to put on top of our lib file. So let's write the following. We're just going to import the libraries for now because we'll create the set itself inside the run function when we come to that later. Essentially, this is going to be a hash set of visited URLs wrapped in Arc and a Mutex, so every task can share it safely. Once it exists, a task locks the set before crawling a URL and inserts it. If the URL was already there, the task will skip it, and that's how we make sure that each page only gets fetched once. So if we spawned a task for every link with no limit, we'd be sending thousands of requests all at once. A semaphore is going to fix that for us. So each task will have to grab a permit before it can fetch a page, and there are only so many permits to go around. So let's write the following. First, I need to import the semaphore. Scroll down to the bottom, and let's write the following. Okay, so holding that permit in a variable means that it gets released automatically when the task ends, which frees up a slot for the next request. So the task fetches a page, and then under the visited lock, it keeps only the links it hasn't seen before, and it returns those for the caller to queue up. Now we're going to implement our driver, which is going to tie the whole thing together. So in a new function, which we're going to call run, main will be able to hand this function a seed URL and a page limit. We're going to normalize the seed and then seed the visited set and a join set with it. Then we'll loop through it, and as each task finishes, we spawn a new task for the links that it's found. A running count of the pages we've set off to fetch is what's going to stop us. So the limit is going to count pages fetched, not links discovered. Join set is going to be a new import here, so we can do that by importing it from the Tokyo task library. And now let's write our run function. So the join set is going to keep track of all the running tasks. And join next hands us each result as it finishes. And the semaphore is capping us at a maximum of 8 requests. So no matter how many links turn up. Now, when you're building a web crawler, please crawl responsibly, add a small delay between requests, make sure you're setting a descriptive user agent, respect a site's robots file, and only crawl sites that you're allowed to. I'm crawling my own blog, so it's fine, but please crawl responsibly when you're building your own web crawler. Okay, our library's finished, so now we can go into our main.rs file, and we can actually use it. So let's write the following. All right, I'm going to open up a terminal and let's type cargo run. And there we go. So it's visited some pages on my website. So if I go back into the code, I can see that I'm limiting the maximum pages to 10. And it's gone ahead and crawled my website and returned 10 URLs back to us, which is pretty cool. So that's pretty much it for building a web crawler. For some stretch goals, if you want to extend it, you could pull each page's title out of the HTML and save it to a file. You could do things like swap the handwritten link scanning for using a scraper crate instead. Or you could add a small delay between requests to be even gentler on the server. But for now, let's wrap up the video. So in this project, we built a web crawler that fetched pages asynchronously. Each request used request and await, so that while one page was downloading, the program was able to start other downloads asynchronously. We also built the web crawler to visit each URL once, so we had a shared set of records that pages had already seen, so we never fetched the same page twice or loop forever. We stayed on our one site, so we stayed on my blog website. We built a function called extract links that kept only the same site links and skipped things like assets or other web pages. So our web crawler was smart and it didn't wander off to other websites across the internet. We also learned how to share safely using Arc and Mutex. So we built a set that lives behind the Arc and Mutex crates, the same pair that we used for shared state. So every task can co-own it and only one edits it at a time. And finally, we learned how to bound requests using a semaphore. We use the semaphore to cap how many requests run at once, so we weren't sending thousands of requests all at once. So thanks for watching. If you like this video, give it a like. If you want to see more videos on Rust, don't forget to subscribe. If you have any questions, pop them in the comment section below. And as always, the code that we've covered in this video, along with some other key resources, will be in the video description. Thank you so much for joining, and I'll see you all in the next one.